I wanted to ask Sam, going into the topic of technical considerations and approaches now, maybe Sam, you can answer for us. How can hybrid edge technology, cloud technology, sorry, enable the adoption? Well, we touched on this a bit, but maybe just expand a bit on how it can enable the adoption of AI related applications, and some of the use cases we didn't really get to ask you about that.
Sure, thanks, Journey. So basically, let me maybe answer this in two parts. One is that when it comes to the AI, the world of AI and machine learning, the whole concept was adopted after human intelligence and thinking process, right? So which kind of it's the way we think and we learn is in multiple parts. One is the central knowledge that we learn and read and get new information on ongoing basis. Then we process it locally. We have our own brain, so we don't rely on others. And then we experiment with the knowledge. And then the third level is communicating with other humans, and in exchange of the information and knowledge, our knowledge gets more and more optimized, and then collectively we send that back to the central place and get that information updated. Now, that's exactly how we're applying our technology into this whole arena in the AI and machine learning space. The way Mimix Hybrid Edge Cloud platform works is that now we're decentralizing the systems and workloads when it makes sense off to the devices where the applications are running and generating data. We're putting data into action right at the edge. So there is the training that Vera and everyone mentioned that is happening in the cloud on ongoing basis that gets downloaded to all these devices that is sitting on the edge. Then the device is also feeding based on the data that is getting generated on the apps on the device, and is getting more and more optimized. And then it starts to talk to all these other devices and nodes and sharing knowledge, and it's getting more and more optimized. So one thing to note is that our platform really enables the devices to now form clusters based on network, proximity, and account, and start communicating with each other and share knowledge, and even microservice, which is functions like push functions to each other in a peer-to-peer fashion, and also push AI model. For instance, now to give you an example, I give you a couple of examples. One with, let's say, CCTV cameras around the world. So the way it works right now is that there's this central control unit. People are sitting behind it, watching everybody or our lives to get information. Now, in the ideal and better world, the way it would work, let's say they are looking for a criminal and they have a model of either the face of the criminal or the plate number. They would push that model to all cameras. Now, cameras start looking for that person based on the model that is running. One camera detects the object, takes a picture, sends it to all the other cameras, send a notification back to the central control unit, as well as sending a notification to the local law enforcement office that, hey, I found this. So this is a true collaboration between all these devices based on the information from the central unit, and as well as itself running and optimizing and sharing with others. So instead of now everybody looking for everything, they're looking for a specific object and putting it more in a much more efficient way. Another example to give you, which is basically a use case that we developed with one of our partners in the automotive space, and it's something that is happening today. I'm not talking about future. That's in automotive smart cities. So imagine there's a car driving down the road. The car has a camera built into it. The camera has the AI model of obstacles that is loaded onto it. Now the car is driving down. It detects an object or an obstacle ahead. It takes a picture of it. It sends it to the car infotainment system on the LCD. The driver will see that there is an obstacle coming, is ahead. At the same time, it sends the picture to the other cars in the vicinity, notifying them that there is an obstacle ahead. It sends a notification it sends a microservice to the smart traffic light, that now the traffic light turns from green to yellow to red, back to green, to slow down the traffic. So at the same time, now it's communicating with all these other devices in a peer-to-peer fashion, and all of this without even the need to go to the cloud yet. Right? So this is how we are seeing, and at the same time updating each other, because these other cars didn't have the model of the obstacle. Now it's taking the picture and sending it to them and sharing knowledge with them. So this is how we see the world is moving forward. And this is how Mimic is basically participating in this whole thing, is simply bringing all of these compute to collaborate together when it makes sense, and putting the AI also into context, because AI is something that is not one big brain sitting in a central place. It's in every device, and it continually getting more and more updated with information, with data that is getting generated on the edge on these devices. And then collectively we're building this super AI, which is based on the collaboration amongst all these devices. And what really Mimic is enabling the devices to now communicate independent of the device type, device OS, network connectivity, and cloud connectivity. We even enable devices to talk to each other when they're offline, like without having internet connectivity, which kind of rural communities come into play in that angle. We're really horizontal. We're breaking through, we're breaking through vendor lock-ins. We believe the whole ecosystem needs to work with each other, and it needs to work seamlessly in order for us to achieve this ideal case that we're all envisioning. And we've made it super simple. I think I put it in the chat earlier. Anyone in the audience that is a developer or working for an enterprise, you can go to developer.mimic.com. That's where you can get access to our platform and start playing with it. It's available for almost all operating systems, and there's nothing new that you really need to learn. It's basically we're the same software development methodologies and that you're using today for cloud deployment. Now you're using it for your front end application development. So that's what we're basically adding to this whole mix.
Great. Thank you so much, Sam.